Hey, welcome back to the stream. Second stream in the day if you've been, if you managed to catch the other one. If not, try to give a quick recap of what we're doing here. So this is a bit of a little tangential side project. It doesn't have that much to do with any of the other recent projects. It's a bit of a continuation from some work from summer of 2016, where I was doing some tablet-related articles and work on like doing weird hacks on graphics tablets. And one of those that didn't quite make it to fruition in that time frame was a little robot that would skitter around on the surface of a tablet with some kind of vibrating brush motor bits, and then draw on the tablet with closed-loop feedback in order to direct the motor around and actually draw something with this combination of the random aesthetics and some intentional control. So let's go back to the desk here. Ooh, did I format this already? You can never be too formatted, right? You actually can, but I'm just going to ignore that. So yeah, there's so much going on here. So this was the first robot that we built. The 3D printed part of this came from that original 2016 design. Oh geez. I don't know if I can trust the autofocus this time. Come on, Servo AF. Nope. Alright, twisting the ring today. Alright. Yeah, so I made this in 2016 in Fusion 360, I think. This whole thing is a single NinjaFlex print, printed with supports, which I had to remove. Printed with the print bed like that, and these legs were actually a good bit longer in the model, and then I ended up trimming them because it turns out that the nib of the pens I ended up using does not go very far down in there. So in order for the nib to have really any chance of contacting the surface and drawing, I needed to trim these in order to adjust it. And this design was actually not too bad, and I produced some images that are actually halfway decent with it. Not quite as much as I'd like. You know, there's certainly work to be done, which a lot of it went in, a lot of that work has already been done. We spent some time working on the software and making the whole thing just generally a lot more more carefully implemented, so that it should be doing more of the right stuff. But there's still been some challenges in actually just getting the robot to move in 3 separate directions, because that's the basis of how the software actually tries to draw pictures with this. So the idea is that you're taking some random motion around the page, but then you're able to figure out by averaging out those vectors what those different vibration motors actually end up doing. So a lot of the time they'll kind of randomly bounce around a little bit and then kind of move in one direction, but then kind of end up veering in a particular way as they start vibrating. And with that, you can actually, with enough averaging, which we finally got that in the last couple of iterations of the software, it'll figure out that, well, this motor causes it to move this direction, and this motor causes it to move this direction. But, in this design, it wasn't quite that straightforward, because actually the direction depends a lot on where the wire is hanging from. The wire is really way too heavy relative to the robot in this design, and this robot is heavier than the next one that we built. So despite that, this one ended up drawing some alright stuff. Let me just show those pretty quickly in case you haven't seen those from the previous couple streams. We have this little young robot that's not very good at drawing yet, but we have a few things that are worthy of going up on the refrigerator. So it's just so this was made by this robot with a felt tip marker in the middle, and these vibration motors, and the Raspberry Pi was hanging from a stand up here. And I think part of the reason it worked was that this cord was actually quite twisted at the time, and I think that was causing a good amount of kind of counter tension that kept the rotation in an equilibrium state, while also allowing this thing a good amount of freedom to move around without the cord changing the orientation of So I think part of what happens here is that this robot is very sensitive to the balance between the depth of the nib here and the depth of all the brushes, because there's really no automatic leveling here. You know, 3 points are easy to balance on, but here we've got 4 points, and so the pen has to be adjusted just right so that it makes contact with the paper, but we're still getting good contact between the brushes and the paper, so that this can actually have some locomotion. And so that's very fiddly to get right, and usually what happens is you end up with 2 brushes making much better contact than 1 brush, and then that ratio of which one's actually making better contact actually changes depending on how the wire is pulling the robot. And the software can adapt to that to some extent, but the more it gets surprised by what direction the bot is moving, the more it ends up coloring outside the lines. So there's that. Then, you know, a few others. This was like an attempt at shading. Like, it's supposed to be like dark on the edge and then there's like a lighter spot. But shading needs a lot of tuning before I would expect it to work right. That one's just a scribble. That's like a fuzzy Tuco head. A couple of more tests of that same RNG test image. So like these are just some examples of what it has drawn so far. And I think pretty much all the successful ones here have come from the first iteration of the robot. The second iteration of the robot has been a really useful debugging learning experience, but it hasn't actually been good at drawing really yet. I like this one. This was, I think, as I was tuning the algorithm in a few different ways. But you can see the strokes more clearly in this. Yeah, and Nick says if it keeps practicing, it'll be quite the artist when it grows up. Yeah, that's the hope, right? Another cool one. So yeah, those are some that I like. It's produced a lot of junk, though. I've been recycling some of the junk into robot parts by making some of the robot bits out of paper. So, yeah, so this was the first revision based on that 3D print from 2016. And so I printed this back then too, and I just like had this part sitting around with the motors in there, but I hadn't actually gotten a chance to write the software for it or actually add the coil that emulates the pen. And I had been really way overthinking it and assuming like, oh, well, this one's just to test the locomotion, and then I'll do a second design that includes the tablet transmitter thing. But, you know, that's like way too complicated. I already had this printed, and it was most of what I needed, and I was impatient, so I wound the coil very carefully around just this exposed slanty bit of the 3D print, which was a bit challenging because of the geometry, but then I just glued it in place once I had it there. And this is only like 20 or 30 turns of 32 gauge wire. It's a pretty small coil. Does not have to have any really particular inductance because the way I'm driving this, I'm not relying on a resonance. I'm just like driving it straight to the frequency I want it at, which is really inefficient, but it's easy to make a tutorial around because you don't really have to be accurate in any sort of way. So yeah, and I mean we're only really talking about driving like 5 or 10 milliamps into the coil, so it's still not too bad. It wouldn't be great if you were running that off of a AAA all day, but for something like this that's tethered, it's fine. And these have little brush legs. You know, as I said, I had to trim them, but I think they actually ended up working all right. I was really kind of negative on them at first. I was like, well, they don't even really seem to be making that much contact. They seem, you know, I described them as being more like training wheels, and that I thought a lot of what was actually going on is that the vibration was acting like a lever where my theory at the time was that the most of the mass was up here because I had this big old pen attached rigidly to this base. That was acting as one whole semi-rigid system. There's some damping in here, which I like because that prevents the vibration. The damping allows the different legs to be more different in their effect, I think. I think you wouldn't get quite as much of that with rigid. Although we were talking about more rigid designs in chat, and I know I've been skeptical of rigid designs before, but I think I'm coming around to like a fully rigid design might actually be fine. Because then, just because of the geometry of the motion, for example, if this was fully rigid, you would still have this leg, for example, if you had this motor turned on, it would start bouncing primarily in this mode, or at least that's the hope, and then that would cause the motion where these, so then the locomotion actually occurs when this kind of presses against the surface and causes, so let's see, how does that work? it causes the whole body to scoot left as those bristles bend, and then as the vibration bounces back up, then the bristles slip against the surface, and then it retains that position that, after it's scooted leftwards. So then it just does that over time, and each cycle moves it very, very, very slightly left in this example, and so then it moves across the surface, vibrating. So the idea is you want the robot to be designed so that you can do that somewhat independently in 3 opposing directions, and that's the minimum that you need to get around on a 2-dimensional plane. So yeah, and this one has actually been surprisingly effective, mostly by accident, but it's been a really good learning experience. The main failing of this robot is it's, little things like it's not as reproducible as I'd like. It seems to kind of unnecessarily use 3D printing. I might do a 3D printed version of this, but it would also be nice to do one that doesn't require 3D printing. It'd be nice to probably have both of those designs available. So, that's not really a negative, it's just like, well, I'd want another design also. The main negative about this design really is that it's just not adjustable at all. So, as much as I like having one rigid body like this, the problem is if this bristle is just, due to the shape, is pulling it in like a circle like that instead of, so a lot of times what'll happen is instead of pulling it straight, it'll actually kind of pull it like that, and you'll just end up not really making that much progress. And so that's not terrible. I mean, the software we've been working on can work with that, but it makes it really hard for this to stay in the lines if you actually want it to accurately draw anything. So it would be great if you could adjust that. I've done that to a very limited extent on this robot just by trimming the bristles with edge cutters, but it's really hard to do that accurately, and I've done a kind of lousy job on it, honestly. So that's not so great. So, and then the next version of this I did, do I still have that? How's this thing? I already disassembled the vibrating motors off of it. They were attached kind of in this knee area at the bend. So the idea I had was that it would cause mostly this sort of vibration, where it would kind of act like a ratcheting leg that kind of scoots it across the surface using a difference in how grippy it is in one direction versus the other. But that failed for a couple of reasons. I think the legs, no matter how I adjusted them, I could only just barely get them to work really well. This adjustment here, we managed to occasionally get this to move in 3 separate directions, but it was pretty unreliable. I think it was kind of hard to tell how good or bad the feet were in this design, though, because the main problem we had with this design was that the wiring was just so much heavier than the actual robot. So this one's actually really light, and it's lighter partly because the motors and the body are just so much lighter than this one, but it's also lighter because this was also where I started decoupling the robot from the pen. So it solved the balancing problem where I was trying to balance evenly on 4 points. If I could have the robot balance independently on 3 points, and then separately there was some kind of bushing that allows the pen to slide up and down and then balance independently. So that's what I ended up doing with this. It was kind of by accident. I initially sized this to fit my big felt tip pens here, but someone suggested in the chat that we try something that could allow that slide, and so I tried some thinner things like pencils and charcoal sticks that I had handy, and that actually had some really nice advantages. The balancing was super useful. The downside then is that this whole robot is now effectively super light because it's no longer rigidly attached to the pens. So now this thing just skitters around without that much control, and like it just vibrates the whole thing really easily. So one response to that, well, and I guess critically there was that this thing did not really have much ability to control reliably because its weight was just so small compared to the weight of like all the random like silicone wire attached to it. So that was not great. And then I was hoping to do something where I had a bolt as a mass in the center of the robot, which would also double as a nice rigid attachment point to the paperclip, and then some kind of triangular arrangement that the pen goes through. There was going to be like a paper sleeve in here to provide a little bit of spring force to keep the pen centered while still allowing it to slide up and down. And then the idea was that the vibe motor here would then go really close to the foot, and then it would end up kind of vibrating this whole leg, and then kind of providing that same scooting motion. And then I tried a couple of different feet. At first, the same kind of just like pointy inward kind of normal cylindrical foot on the paperclip, like without any special processing. I tried filing down the edge into a sharp point. I tried these little boots made of heat shrink. And nothing really worked that well. It seemed like a combination of problems. One problem is that these bolts are just like, they make the whole thing too heavy, so I think I just used bolts that are too big. These are M6 by 40, I think, which I could definitely try smaller bolts. I just also don't know if the approach is actually any good. I've been preoccupied with a bunch of things, but part of it is all of the designs so far that have used the wires, so like the second and third designs, those have all just been ridiculously sensitive to the tiniest aspect of how the end of the paperclip is pointed or shaped or anything like that. And that just seems like a bad thing to introduce into a project that I'm trying to make like easy and fun and reproducible and like a fun thing for kids to do, and like, you know, just like a little weekend project you can do easily, right? So that's no good at all. Whereas bristles seem pretty reliable, especially if you can start with some kind of commercial product that's easy to modify, like a toothbrush. So that's kind of having me go back to either, you know, and 3D printed bristles are still not totally off the table, because I think the 3D printed NinjaFlex brush thing actually was working all right. I would just probably need to have some kind of wire armature in there that you could twist in order to adjust it, or just 3D print it as separate parts. But my current idea is that maybe still forego the 3D printing just to like keep the technology stack a little bit simpler, and instead, since basically we still need something that can adapt to the shape of like a random off-the-shelf brush now that we're using in a random off-the-shelf brush. So you could like epoxy that to a 3D print or something, but that's a whole bunch of problems. That's like more stuff on the parts list. That's like a bunch of weird glues. And then like if you're using PLA, PLA is actually pretty hard to glue reliably too. So that's just annoying. So it would be nicer. Well, and then you could use bolts like this, and that would be all right. But you still need to attach something to the toothbrush, so then there's like more epoxying or something. So that's why I was thinking about more of this shape lock plastic, which we used a little bit of on the last stream. And that's this low temperature melting plastic. When it's cold, it feels a lot like nylon. It's really hard, it holds its shape really nicely. If it's thick enough, you can use it for mechanical stuff and it stays pretty rigid. But you can also work with it at temperatures that are fairly safe, and you can still burn yourself, but you can like also mold it by hand if you don't hold it for too long. And it's like pretty easy to work with. You can heat it with a heat gun, which is what I've been using, or the usual way people recommend in like classrooms and stuff is to just use like hot water, I think. The water is actually pretty convenient. The reason I dislike it usually is that then you have water in your plastic, which can get stuck in there. But yeah, it's actually pretty nice stuff. It's convenient. It goes by a few different names. It's what is the name of the actual polymer? It's polycaprolactone or something like that. But yeah, it goes by names like polymorph, instamorph, shape lock. So that might be one thing to try. I want to see if it actually sticks to the toothbrush head. First to-do list is I went toothbrush shopping. We need to see if the brushes are actually any good. A lot of this relies on the bristles having a uniform-ish slant to them, and toothbrushes are complicated, and we might have to do some toothbrush surgery. So we'll want to do some little tests and just see which of these are actually good at being little vibro toothbrush bot things. Once we find a good toothbrush, I want to see if the shape lock plastic actually sticks to it. And then I think what we're going to do is make something where there's a central hub of some sort, probably involving a triangle of paper clips of some sort. I don't really exactly know how that part's going to work. But then that central hub will then have spokes that attach to each individual toothbrush motor. And so I think what I'll end up wanting to do is find a way to twist the toothbrushes together. So I'll start with 3 toothbrushes, twist them, so I end up with a triangular hollow spot in the middle, and then 3 arms that all come off and then end in a U-shaped bend, which I can then incorporate into the shape lock plastic on the toothbrush foot. So I think that's the plan. That's as far as I've gotten, at least. Also, do we have a cat that I can stream for you guys? I don't see the cat down here, but I'll let you know as soon as he's within camera range. I can get the bot started up. The bot is currently staring at the gimbal right now, which is not so great. Yeah, right. James says, if you're targeting youth/schools, then I suspect 3D printers are an easier thing than epoxy, which is a little bit bizarre, but I totally agree with that. And yeah, so if this gets to the point where we're thinking about using like weird adhesives and stuff, then let's definitely just like switch to CAD and make a 3D printable piece. The thing that has me, so I'm really close to thinking like, let's just like make it all 3D printable, whatever. The thing that's keeping me from going quite there right now is that doesn't solve the problem with how do you attach it to the toothbrush, unless you are dealing with enough of the toothbrush neck to make some kind of clamp or something that attaches to that. But that's really at odds with my desire to make this whole thing pretty low profile, so that see how this whole thing is pretty small diameter? That's going to be difficult to achieve with a lot of these means, because that's really nice because it can get pretty close to the edges of the tablet without falling off. But, I mean, yeah, I guess I'm forgetting that, like, we could still use these bristle things, and then just either 3D print it in multiple parts, have the armature, or whatever, so, I don't know, that could be it. James says, now I'm envisioning a 3D printed pen holder with small non-vibe motors that you attach 3 electric toothbrush heads to. That's a completely different project, though, probably. Non-vibe. Oh, so they're like the kind where you have like the motor shaft pointed at the page to make a little wheel. Oh yeah. Oh, we got some good questions in YouTube chat too. Let me try to give a quick recap here. Got a good evening from Mike's Radio Repair. Hello, and hello from Andrew. Nice to see you again. And then Suddenly Corporeal, which is pretty cool, Nick, says, thanks for the recap. Any thoughts about going wireless with this bot? Yeah, we thought about that a little bit, and this is a pretty good question. We could recap some of the wireless thoughts, too. Yeah, so I mentioned a strategy where we might use like infrared sensors to send the data optically, and then someone else mentioned in chat doing it with photoresistors. And yeah, so that might have the advantage of also kind of adjusting for the rotation of the robot automatically. So you could say like move left, and you would end up broadcasting that to whichever motor was on the left. So that could be pretty cool. That's definitely something to think about. I mean, that complicates the project slightly because now you probably need some onboard electronics to generate the tablet signal. I've been doing some tricks where I encode a little bit of data in the tablet pressure for a few reasons, partly to keep the tablet in its fastest sampling mode, and partly for some timing information, and partly just to make sure we get events at a consistent rate. So stuff like that, like we might end up needing to program a tiny microcontroller to do that and stick that on the moving part of the robot, for example, and then have the whole thing run off of like 3-volt batteries. So yeah, that's starting to converge on something where like whatever form it takes, the moving part of the robot probably needs a microcontroller just to generate the tablet signal, if nothing else. And then if it's doing that, it can probably also switch the motors And if you're doing IR, it could just demodulate something you send over consumer IR in a big old blast that covers the whole area. So that would be really simple. A lot of cheap like indoor helicopter toys work like that, where you have an infrared remote control and then just like one of those consumer IR receivers and a little 8-pin microcontroller that drives a couple of FETs. Like you could probably actually mod that. I wonder if you could actually just build this robot directly out of the circuitry from one of those helicopters, because it's got a rechargeable battery, it's got approximately the right motors, it'll have 2 motors, which is not quite as much as I'd like, but if I start with a quadcopter, the quadcopter is not going to have individual control over the motors. It's going to be trickier, and it's going to have like onboard IMU and stuff, but maybe you start with the quadcopter but replace the integrated circuit with something else, but now it's like a much more complicated project, so I want to avoid that. Oh yeah, and I'm getting to that, but actually two people asked about Sugru. Oh, actually it's just Andrew on both chats. But yeah, and asking about Sugru, that's a good question. I don't currently have any Sugru. I bought some a while ago, but it actually does not have a very long shelf life, so none of that is still any good. We could make some, what is it called? Ugu, the like knockoff Sugru that you can make out of cornstarch and RTV silicone. I have a ton of RTV silicone, actually, which I know is still good because I used some of it recently. Oddly enough, I don't know if I have any cornstarch. I could have bought some of that while I was buying toothbrushes, but I didn't think about that. Andrew suggests using an old PowerBook as the controller. That's a strange suggestion, but I guess you could do that, sure. But yeah, Sugru is an option. I was going to use the shape lock because that's what I have, and I think in this case having something rigid would be preferable to having something squishy, and this is nice like that, so that might be one of the first things to try. Is just so like I think we're starting to develop a list of like what to try. It's like, well, which of these toothbrushes are good? I tried to buy some that seemed plausibly all right. How do we want to cut the head off of them? Hacksaw, soldering iron, like what's the preference here? Probably like hacksaw or like sturdy clippers or something. And then test the vibration. So that might be an excuse just right away to try sticking stuff to it, because like it's pretty easy to just like use the parts that are right here on the desk. This is one of the vibe motors we're using. They are deceptively strong for their size. These come from Adafruit. They cost like $1.75, I think, and it's a tiny off-center weight in a sealed can that goes like 11,000 RPM at full speed, and it runs off like 2 to 5 volts. And here I've just got it soldered to some thin magnet wire that I've twisted together. So, and then this is a silicone kitchen pad, which I just have here because this stuff is super messy and it will stick to most surfaces, but it doesn't stick to silicone, so I like to heat it up over a silicone pad. And then, let's see, I think I'm almost done through the, I know there's so many more questions. Sorry, I'm not quite getting these in order. Mike's Radio Repair says, have you considered using a coiled microphone cord? I don't know about microphone cord specifically, because I think we need something that's really tiny. So like here's the wire leash that I took off of the second robot that I disassembled. I mean, this is about to stop recording. So yeah, while I was disassembling this robot, I took this leash off of it, and this is way too big and way too heavy. So, and I think most off-the-shelf cabling is probably going to end up being not as lightweight as this. I mean, there are some like miniature USB cables and stuff I can imagine being smaller than this, but it's the thing that I'm probably going to do for cabling is something more like this, where I twist together many strands of 32 gauge magnet wire. And then I haven't done it quite yet, but I could actually. I was going to give this another layer of coiling. So, in fact, I've completely lost the polarity on these. And I already enamel coated the joints here. Oh, there might be a tiny bit of metal poking out that I can use to measure polarity, because I would like to save the polarity. I don't know whether these motors have directional brushes in them. They probably don't, but just to be on the safe side, it'd be nice to run them in the marked polarity. So, can we get to either of these? Oh yeah, there's a little bit of exposed metal there. That's 0 ohms, so that's probably minus. I don't know if any of the plus is exposed. Oh, tiny bit. That's 30 ohms. Cool. Okay, so this one that's bent back is minus. I should label that somehow. Maybe with a little bit of blue tape for minus. It's also distressing that it was that easy to find a spot that I could measure through the varnish, so I guess I need more than one coat, which is not surprising. I probably should have read the instructions. I wasn't really that concerned, I just wanted something that was better than nothing at the time. But yeah, it's probably not that great. I can go ahead and put another coat on it. I was actually about to think about maybe putting some heat shrink over there. It's a bit of a messy joint. I should really resolder the blue one to make it less long. They ended up non-uniform lengths because I ended up having to redo one of them when the joint broke. I should also not worry about it too much because this whole thing is just temporary. That piece is too big. I should use the other piece that I cut off. This is also maybe a case for a little tiny piece of blue heat shrink. I just don't know if the heat shrink I have handy will actually, once it's shrunk, be small enough for this 32 gauge wire. This stuff is so little. Alright, so I'm got a little blue flag on the minus now, so I can kind of tell them apart. And okay, so I can kind of straighten that out pretty easily. Oh, that's fine. I can just leave that like that and then put another coat of enamel on. I mean, I probably shouldn't insulate it that much right now, given that this is a temporary test fixture, but I would also like to test the insulation, so that's part of why I'm doing this. Since I kind of like this as a method for like really lightweight insulation, especially when the wire I'm using is enameled anyway. Sorry, I got that off frame. I had to twist it a bit to avoid drips. Oop. I just dripped enamel on my silicone thing. I guess this is graduated from kitchen equipment to shop equipment. That's fine. Oh, microphone cable. That, I see. That's interesting. That is interesting. I think that would still be way too heavy for this, but that's a really interesting suggestion. Yeah, I would need more conductors. I would need, this robot, the way it's currently designed, needs 5 wires. Alright, I think that'll be alright. This looks like I'm bleeding, but it's just the paint now. Andrew suggests using MET for power and ground and one wire for the microcontroller. You're missing the part where this is supposed to be simple. Part of why I like doing this off the Raspberry Pi is I can just do everything in one platform, in one file, in under 400 lines of code, without having any communications protocols. I mean, there's a little bit of inter-process communication, but I'm using like pretty transparent ways of doing that from Python. So, been really aggressively trying to keep this thing simple. So, there might be some ways that I can use fewer. I mean, I can use fewer wires, of course, but that's the only way in which it makes it simpler. All right, so I think braiding together like 5 32 gauge wires is the sweet spot here. That's what I'm going to try next. That's just not quite the fabrication step I'm at right now. Right now I'm testing vibration modes on the toothbrush. And thinking about how to mount this stuff so it stays really compact. That's why I'm liking the idea of drilling a hole in the toothbrush. Okay, maybe I have not mentioned this on the stream yet. I was talking about this in the chat between streams. That there's a strategy that I like in a lot of ways, except for the part where it would require the tools list. Probably basically require it to include a drill press for this to work right. You could maybe do it by hand, but it would be a pain to drill a hole in the toothbrush by hand. You'd want a drill press and a vise to do that. I guess you could do that without a drill press if you had a vise. Oh, sorry, I'm reading Keith's paragraph. Oh, okay. It's another another question about measuring orientation. So yeah, it's come up a couple of times that we could try measuring orientation by using multiple coils and sequentially pulling them. That's certainly a thing we could do. It would decrease the sampling rate significantly because the tablet, the way it works internally, it doesn't actually have the bandwidth to sample the entire surface of the tablet at its full rate. So it internally has an algorithm where it tries to localize the pen and then refines that estimate over time. So you'd have to find a rate to switch your coils at where you'd be like kind of compromising between your overall update rate and the amount of accuracy you'd be retaining from that filtering algorithm. So it'd be a little bit tricky to do it and still get good results, but it would be possible for sure. And there are nicer tablets that actually have legit support for multiple transponders simultaneously. I have not looked at how those work, but I know Wacom has some that worked like that. In fact, I think my Intuos, the tablet, has support for that. I just only have one pen for it. So it might be fun to look at that. I think it's time to look at the brushes I got. Next Radio Repair says, I'm thinking you could adjust the weight by adjusting hanging height. It's like a spring. So I think we're still talking about the microphone coily cords. And then generally offering a small sample, and that they make, okay, yeah, they make microphone cords with like 4 or 5, 6, 8, etc. conductors. I think I've already been down that road, because with the silicone wire, like, I could kind of get it out of the way. I could add and remove elasticity. I could hang it. I could adjust the hanging height. A lot of the successful images that I got with that first robot, I got them by just like endlessly fussing with the exact way that the wires hang. So that's certainly possible. It's just something that I'd really like to try to remove the influence of that as much as possible. And that's why I really like using the magnet wire, because that just really drastically decreases the weight of the wire relative to the weight of the rest of the robot. And I can also, like with the silicone, I was really limited about the length because I was trying to get away with just like 1 2-meter pack of wire. Whereas with the magnet wire, I'm probably just gonna like include in the materials list just like a whole spool of this or something. And so you'll be winding a coil with it and then also using a bunch of it to make this potentially longer leash that, oh, that's right, the next thing we were gonna do with this is actually coil it. So I don't know how far down I want to go with this ultimately, but yeah, I was thinking that I just give this a secondary twist where the whole thing, I mean, I'm hoping this is flexible enough, but also does a pretty good job of supporting its own weight. So something kind of like that. That feels pretty nice, actually. I would definitely want this to be longer, because at this level of twist, like, you know, springiness, like that actually does a pretty good job of just like kind of staying out of the way, but only for a short distance. I think I just want to use a lot more wire. But anyway, that can save that. I can save that for the next fabrication. All right. I got some of these bigger brushes that we could experiment with if we're into cutting sections off of larger brushes, pulling bristles off of brushes, making larger things maybe, but that's less applicable for this project. For this project, I thought this would be most useful as a source for cutting sections out of with a scroll saw. So what I'd probably do is cut off the handle with a hacksaw so I could get this flat against the scroll saw table, and then use the scroll saw to go in between the bristle clusters and cut out like kind of chevron-shaped pieces that I use for feet. So that's one option. It's not quite uniform because this is a little bit like kind of hourglass shaped. Oh, James says also means that if you have a class of students, you can probably just get one spool. Oh, if I'm running workshops myself, I think I've already got enough magnet wire in this shop for dozens of people's lifetimes, so I don't have to worry about buying magnet wire anytime soon. I decided to buy, like, I think a kilogram spool of 32 gauge wire a while ago, which is, turns out, a lot of 32 gauge wire. It wasn't that expensive either, it's just that it's like a lot of wire. It's very fine, it's very long. So yeah, for big classes, it's certainly easy to share. And so yeah, I'm tempted to see what we could do with this on the bandsaw, or the scroll saw. I'm just worried about how it's not quite even. So if we start taking pieces out of it, then the pieces, we're gonna have to design the pattern carefully to try to keep the pieces even. The other thing is that the bristles are mostly perpendicular, so we would have to do something on our own to angle them, either by trimming the brush or by like angling them with heat, maybe hit them with the heat gun while this is pressed down. I don't know if that's a good idea. So yeah, this, oops, I could test the durability of that. It really disappears on that orange silicone pad, doesn't it? So yeah, I got a few of these. I don't know how useful they are, but they seemed useful for materials at least. And then I picked up the most promising, like, cheap toothbrush value packs that I could find at Target here, which was like the place within walking distance I could go to get a bunch of toothbrushes. So yeah, what do I think about these? These have a very slight angle, so they're not angled very much, but the angle seems consistent at least. Like all the bristles have the same exact tilt. The downside is the waviness means that only a little bit of the brush is actually going to be contacting the surface. That may or may not be a problem. So these seem promising, like they're not ideal, but they might work without any modification. They might work even better if you even the length out on the bristles. And And it might be that the bristles end up spreading out on their own enough that they kind of self-level, and none of that ends up mattering that much. So I have high hopes for these. I think they might work all right. This is the Oral-B value pack. This was the store brand Super Clean. Oh, I didn't even notice both of these packs were soft. That's annoying. I was looking to try to find the shapes that would work, and there was just so little selection there that I didn't think to look at the hardness, but it looks like we've got soft bristles, which is not... Like, I don't know how much that matters. Some people were saying on chat earlier that hard was a little better. Don't know what the physics is behind that. So anyway, what's going on here? These also have... These, I don't see any angle here. So these, I think you'd need to adapt them to have an angle by like trimming them or angling the whole head. So they're a little wobbly. No angle. So these are not great, but I thought they might be worth a try. And then these were interesting. These were another store brand pack. Just like trying to emulate some other brand. And they're also soft, which may or may not be bad. They had this interesting pattern where there's a really steep angle going one way, which extends all around the outside. Then there's an opposite angle going this way. So this caught my interest because I thought with these, well, this outer angle is actually pretty great. Well, actually, which angle would I want? I could decide which of those to keep. But my idea is to pull out the bristles going one way and leave only the other direction. And so that actually might be the easiest to get working quickly because the angle is already so good. So I'm going to open this one. Oh, James says 1 kilogram of 32 gauge copper is only 2.2 miles. All right. So I guess I haven't gone through nearly that much in rewiring circuit boards. Maybe I need to do more of that point-to-point wired BGA stuff that people are always posting in Japanese on Reddit. I don't know why I'm taking all of these out. I guess I'm going to need most of them. I'm sure, I also legit just needed some extra toothbrushes to use as toothbrushes, so the extras are not going to go to waste. The ones that are on my desk here, I'm not going to use as toothbrushes, though. Oh yeah, Alice says, or make lots of electromagnets. That is a way to go through this wire very quickly, is just making more magnets. Making big radio coils, maybe. Mike's Radio Repair says, get one of those clear silicone hot glue gun sheets. Yeah, I have actually I have actually several silicone sheets in the kitchen for baking. I just didn't really want to get, commit them to the shop. But, I bought a bunch of these recently, and I think I have more of them than I need, so I was willing to commit them to the shop. So it was more about, what I was willing to get chemicals on than what I had handy. So maybe the first thing to do is to figure out how I want to cut the heads off of these toothbrushes. I think the most humane way to do it might be a hacksaw. Hacksaw blade is bent. This was the saw I was looking for. This saw has seen better days. Let's see if it's still good enough to cut a toothbrush. I like the way Thomas thinks. They say, don't you mean teeth brush? Yes, I think I do mean teeth brush. But yeah, I probably should get a silicone sheet that I can dedicate to the shop, because they seem useful. They just also seem useful for the kitchen. So, do I want to put this in a vise? I think that would be helpful too. My desk is also messy, which makes things hard to find, but then I get lucky and I have a surprising amount of stuff within arm's reach. James thought it was windy in their shop, but they had a game running Skyrim with wind. I should really just grab this by the long handle, shouldn't I? I mean, it's only going to get worse due to that taper. Ugh. The squishy, rubbery handle is really not so fun to work with. So I don't think I need to keep very much of this stock. At least that's my current working theory. I certainly could design like a 3D printed adapter that fits onto it, but that would have to be kind of different for every model of toothbrush out there. And I'd rather design something that's more widely compatible. And so I'm thinking that no matter what the center is, like whether it's 3D printed or just like built with random objects or shape lock or whatever, that I would need like a paper clip as an adjustable interface, and then some way of bonding the paper clip to the brush head. I somehow thought this would be a little easier to cut through. Maybe I'm using the wrong blade for this. I probably just could split it at this point. But... ooh, it's like kind of gooey when I cut it. Maybe I do just want to use something more like this. Oh, Alice has smaller bolt cutters, maybe a little less effort. Yeah, I definitely had big cutty things that I could use for it. I just didn't realize a hacksaw would work that badly, or I would have gone straight for something else. But yeah, noted. Hacksaw does not work very well on toothbrushes. Cool. Yeah, the little cutty things work pretty well too. But I've got like a big cutty thing. I've got... mostly I've got like a big old pair of scissors. I think that's the basic thing I have. I'm just kind of rounding that off a little bit. Alright, so we have one decapitated toothbrush. Oh yeah, I was going to answer Connor's question. He was just asking, like, generally what's going on. Am I putting brushes on a CNC or something? That's a good guess, but it's more like I'm trying to make the brushes into a CNC. So I'm trying to kind of finish this experiment that I started a little while ago, where I'm building a robot that holds a pen over a paper and a tablet, and then uses vibrating brushes to move it around in 3 directions in order to draw images. So, let me grab its portfolio for a sec. So it's been drawing stuff like that. When it gets lucky, it has a lot of duds, but this is like the good stuff it's been doing. Fuzzy pictures of my cat and more text, more fragments of text and stuff. So that's like when it works, but it's also been very, very, very temperamental. And so part of this is trying to design a better mechanical setup for the bot that'll be like much less temperamental and easier to keep stable. are kind of some kind of weird plastic. Yeah, Alice is wondering what kind of plastic the toothbrushes are made of. I think they do make them out of like some kind of especially weird and gummy plastic. I guess it's just a good time to see if the shape lock sticks to it then. I'm guessing I'll have to pull the middle bristles out of these for it to really be good, but let's start out with just this. I'm also going to go ahead and get a little clip tail that I can adjust to try to keep this stable even just during my bit of working with this. I just got to notice that OBS crashed. I think that's the other instance of OBS running TucoFlyer. Just going to restart that and hope it doesn't crash the whole computer in the meantime. Alright, let's grab a green paperclip and let's just do that for starters. I don't think like I want the same kind of like knee arrangement. I don't imagine that's quite what I want, but I think this will just be a good thing I can use to sort of give it a balancing point so that it can scoot, and I can adjust this and watch it scoot differently. Oh, that's an interesting idea. Alice suggests heating up the paperclip and just melting it into the toothbrush head. I'm skeptical of how strong that would be, but we could test that pretty easily on this chopped off handle. Let's try that. These paper clips are coated in plastic, so that's going to be gross if we heat this up. As soon as we hit this with the heat gun, it's going to get all melty and yucky. But for simulating that, like, we could certainly use non-coated clips. And just to see how well this works, I'm just going to grab some tinned hookup wire, and we can just hit that with the heat gun. So I can bend this into a loop. I'll actually just bend it a couple times, and I'm going to twist one end just to have a place to hold it, and then have a loop that I'm going to heat up. And we can just hit that with the heat gun and then stick it into the plastic and see if it actually holds. So yeah, let's test this. And then hot glue. Yeah, hot glue would be alright. I feel like hot glue is too springy. The amount of give that it has is good in a lot of applications, but I think in this case it's going to suck up vibrations that I'd rather be transmitting into the surface. So that's why I'm thinking of shape lock plastic, because it's very hard when it's set. So like that's why I was thinking epoxy would be the glue of choice rather than something like hot glue or E6000. Oh, sorry, I'm missing the context there. That was about just topping off the hole there for reinforcement. Yeah, I see. I think I might try super glue first, but yeah, maybe hot glue would be alright. I mean, it's also kind of unclear just how strong this plastic is to begin with, so it might be moot, but let's find out. I'm going to move this motor out of the way so I don't toast it. I think most of the rest of this is relatively... Oh, I'm also wary about hitting this with any heat because it's going to immediately deform the bristles. So definitely the way we want to do any heat modifications is to heat something else and then stick it in. Which we could also use to poke a hole in the middle if we don't want to require a drill press. So that might be doable. Just heat up a nail or something. I do kind of like that idea of poking a hole in the middle to attach the leg. That still seems like one of those ideas I'm holding on to. Alright, I think we have focus. I think I can just like do this right on top of the silicone mat, which is fun. Although I'd like to hold this in a vise. Let's use a little stick vise. Toothbrush and a stick vise. And so I'm going to try doing something like this, where I just like embed it kind of. How do I want to do that? Well, what am I simulating here? How would I actually attach this to the toothbrush head if I were doing it that way? I could leave an arbitrary amount of the neck free. And then I would probably want 2 closely spaced paperclip ends. So I'd probably be taking something like this and sticking it into something like that. This toothbrush has a very narrow neck, which is not helping. I'm gonna make this a little narrower. Well, let's see what I get with just heating that up. So, pliers. Hold that. And then hot air gun. Yeah, I like the idea of just using the. Okay, so I think cutting it is probably going to be best with just a sharp tool, like something like this. But maybe a hot tool would cut it too. We'll see. Yeah, a central hole with a hot thing. That could really mangle the nearby bristles. That may or may not be a problem, though. No? I could also just apply the soldering iron to this piece of metal. I can hit the piece of metal with a torch. That might be more expedient here. Like, this tool is not going to get it to glowing red. If it looks glowing red, that it's not. It's just reflecting the orange off the pad here. But then that feeds back into the assembly instructions. Like, I don't necessarily want to have to tell people, like, hey, go, like, heat up a paper clip until it's glowing red and stuff it into a toothbrush. Like, if there's an alternative, then I think maybe I'd like the alternative. This isn't even going in. Let me try the non-hot air soldering iron. Let's try just heating up a piece of metal directly. Yeah, Nick says they're going to guess the wire will need to be at least red hot. Well, we could try doing it with the torch. I'm going to try this with the iron first, but then torch is the next step. I've got a... Well, I think the hottest thing I've got here is MAP gas, but butane is probably my first step. Oh, that's melting nicely. If this wasn't such a nice soldering iron tip, I would just go right over the top of the plastic to smooth it out, but in fact, maybe I don't even need a hot tool. Maybe I can just use a metal ruler. Oh, sorry, that was slightly off camera, but... So I just heated up the wire with the soldering iron, didn't have to touch the plastic with the iron tip at all. Then pressed the wire into the plastic, then used the metal ruler to press the plastic over after it was in there. Now it's still pretty warm, but... And I think I could have done a better job pressing that together, but that's not terrible. I kind of like that. And that could go pretty deep into this whole thing. I'd still need some other way to attach the motor. I've seen people use foam tape for that. Hot glue would again be alright, but I'd prefer to use something more rigid. I like the way Nick thinks. Now you have a horrifying implement with a comfortable handle. Well, what have I done? How well does that work as like a pick or something? Okay, how sturdy is this? Is this cool enough to touch? I say after touching it. Yeah, I could have done a better job pressing that deeper in there. Let me try to actually get it deeper in there before I strength test it, because I'm not happy with how far in there it is. This is way easier to clamp in the vise sideways, because then you get to press it directly on the bosom there. Yeah, I like it when people make me laugh on stream. Alright, maybe, it's almost like I need one vise to clamp in this axis, and then this would not be the first time I have used a vise to clamp a vise on this stream. I think most of my stick vices are on the other desk. I keep noticing this comment and smiling, but failing to read it. Mike's Radio Repair said a while ago on the YouTube chat, "Oh, the horror, slow toothbrush beheading." Yeah. Oh yeah, I swear this is not a paid advertisement for Stick Vice. I totally bought these all myself. They're pretty cool though. I have a bunch of them here. There we go. His vice is all the way down. Oh yeah, I agree. Kate says they say you can judge a person by their vices. Yes. I like the way you think too. Alright, so I think the plan here, let's have mise en place, is that what they call it? Having all your shit together or whatever. So I'm going to apply this to the wire. I'm going to push it down with the pliers, and then I'm going to use the metal ruler to smush the plastic down. So my plan here is to hold the wire kind of way back here and then to heat it way up here. Alright, wire is starting to be mobile. I don't know how much I'm going to see the top melt actually if I'm just kind of burrowing down. I'm going to be a little bit persistent here, keep it hot. Certainly more compelling on the first entry than trying to go deeper. Alice says, stick vice held by a bench vice held by drinking and gambling and smoking. Yeah, I like that too, giving it a grip with the pliers. I think also I just happen to have this close by, which is like, it's like another kind of vice, right? It's already hard though. What if I hold it in there and apply the heat? That just sags quickly. I'm going to have to lift it with the soldering iron. Feels like I'm compressing it a little. I'll let off. I don't know if that helped at all. I might have just made it worse. Who knows? You totally didn't see me just blow my nose on a Kim wipe because it was all I had handy. Mike's Radio Repair on YouTube has another great comment. Could always hook the wire up to a power supply to heat it with resistance heating. Yeah. And then Reese Hamlet on YouTube chat is asking for another overview of what's being attempted here. I should keep that portfolio close at hand, really, because that seems to be the most concise explanation. But basically making a drawing robot that wiggles a pen around the page using vibrating motors and sort of brushy or paperclippy sort of legs, and gets feedback from a drawing tablet underneath so that some software can direct it to actually reproduce an image intentionally. So basically a smart kind of toothbrush robot that actually draws. It's for art and for kits. It's like a thing that I hope to turn into a native fruit learning guide and to also produce some art with. So that cools off pretty quickly. Kate says, summary, we're trying to see how many vices we can fit into a stream before YouTube takes things down. Yeah, right? It's funny, like, so far the only thing I've had trouble with is copyrighted music. But the vices, they don't seem to mind. Especially if they're the kind with, you know, spring-loaded jaws. Mike's Radio Repair says that I'm making a tooth scraper. Right. I've just created the worst toothbrush. This seems to be holding pretty well, though. I'm actually pretty happy with this. Like, it's stronger than this wire is. Like, I'm going to fatigue this wire before I mess up the joint at all. So, I kind of want to try this with a paper clip. Do I have any paper clips that aren't coated? I thought I had some that are anodized. Are these all coated? Am I gonna have to wire strip my paper clips? That's stupid. I could heat them up anyway, but that's probably gonna be terrible. I think I can at least partially strip some of these. Here's a little green one. Oh, sorry a bunch of that was off camera. Alice said you wanted firm bristles. Yeah. That is a hard bristled toothbrush. I feel like I should just leave this in someone's bathroom, like at a party. Oof. I'm just gonna leave that elsewhere on my desk and forget about it for a while. Now, I needed to do another test on this, right? I can't just do that. I could use a different part of the toothbrush, though. I could stick it in here, maybe? The end is a different kind of plastic. This overmolded toothbrush is complicated, man. Look at that little nub at the very end. Look at that. You could use this as an eraser. Okay. And this is probably a thermoplastic elastomer, but that doesn't really do us much good. Huh. I guess I'm just gonna have to stick it in over here or something and then see how strong it is. That means I can get down to one vice. Is one vice ever enough? We'll find out soon. This camera gets all cranky when it's about to end a recording and starts blinking, which is kind of useful. Alright, I think ideally I want to squish that into the plastic and see how that works, but it's covered in plastic of its own. I know that this plastic bonds with the shape lock when they're both hot, which is good and bad. It's It actually does make it kind of nice that it's like easy to stick stuff to these coated paper clips with shape lock. It's hard, well, like when you take it apart, that was actually so far the most reliable way of stripping wire off these paper clips is like get some shape lock attached to it and then just pull the shape lock off and it'll take the coating with it. So like you can't quite do this with regular wire strippers. The coating is kind of thin and kind of stiff. And the wire is not malleable, especially like copper. I must just dip these in some kind of like really tenacious plastic. Okay, so I've partially stripped this. I'm going to see if just hitting this with the soldering iron is enough to get it in. So first I'm going to tin the paperclip. I don't think solder is going to stick to this especially well though. Like I think this is steel. They would have no reason to make these solderable. Oh wow, it sticks. Kind of. Yeah, no, solder is wetting this. Why is solder wetting it? They must be plated with something that I can solder to. That's kind of unexpectedly useful. Didn't expect these to be plated with a useful metal. Let's put it in around there. Yeah, that coating right next to the soldering iron sure doesn't like that. I'm slowly getting this into the toothbrush neck. I might just need to use a different, like use my shitty soldering iron that I use for plastic to go back over that. Oh, actually I think I melted it enough that there's a good puddle of plastic in that bend. There's definitely voids there that I could fill with super glue though. Let me try to get that on camera. Oh, James thinks that we just got lucky with the plating that they used to make the paper clips nice and shiny. Yeah, probably. That's about as close as we can get on this camera lens. Oh no, can we get up here? Oh, I underestimated you, lens. Great. So yeah, it's filled in the middle, so it is kind of going to be strong. But you can see how the hole is kind of opened up a little bit on the left, so like a little bit of glue or a little bit of soldering iron would fill that in. Yeah, or epoxy for sure. I kind of want to know how strong it is just right now without doing any of that. I think the answer is plenty strong enough, so whatever, right? Galvanized steel. I don't think you can solder to galvanized steel. I think these paper clips are probably weird because they're coated. Like, I remember not usually being able to solder to paper clips, so this surprises me. I think these are weird paper clips. I meant to get normal paper clips while I was at the store, but I forgot. Anyway, we've successfully made the worst toothbrush. Yeah, this is nice and rigid. This is gonna work. So, I I would still like to know how well the shape lock bonds to this plastic for the sake of attaching the vibration motor. But this means that there are a couple of options. Like if we're using this to attach the legs, then the vibration motor could attach with like most kinds of glue if you had to, or like foam tape or something. Alright, let's see how well this sticks to shape lock. Let's heat up some shape lock and give it some samples. What I might do is stick one hunk of shape lock just directly on the plastic without doing anything. Then do another one where I stick it on and hit it with the heat gun to melt it in. And then also just try putting some like around one of these joints just to see how well that works. And we could do that on this surface of the toothbrush handle because it's pretty clean and it's made of that same plastic. There we go. I just had to get that one out of the way. This really seems like, oh man, I have one of those terrible taser module things. It seems like you could probably use a toothbrush handle as an insulator for those. Oh, interesting. James says you could solder the case of the vibe motor right to a paperclip. Really? That feels like it would overheat the motor. Strufel is making fun of me for soldering to a toothbrush. I agree that this is not a very good toothbrush anymore. I don't intend to use this on my mouth or anyone else's mouth. I do not endorse the use of this device on anybody's mouth. This is no longer an oral hygiene device. Okay, first I gotta heat up my shape lock, which I will do with my heat gun. It's kind of overkill for heating up shape lock, but we'll do it. Ha 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 ha! Oh, interesting. Hovis Spittle on YouTube chats says that Matthias Wandel, the ever illustrious, has a video about using resistive heating to embed wire into plastic. That's cool. That does sound like something he would do. I should check that out. I must have missed that one. And then, yeah, and then Reese is suggesting again to short the clips through a big enough battery. And Mike's Radio Repair adds that the wire is probably tinned. Yeah, it does seem that way. I just don't really know why it would be, because paper clips usually aren't. But guess we got some weird paper clips that are covered in thick plastic and are also tinned. Yeah, Nick says they're excited to see if the polymorph sticks, but then I might indeed get away with the motor soldering trick. Yeah, that seems worthwhile for sure. This also means that maybe instead of having a little loop that goes into the foot and then back out, maybe, I don't know, part of this is like, well, do I want one wire versus two? Like, how much strength do I want? How much freedom of motion do I want? I think I want to be able to define, I'm overheating it in one spot, aren't I? I should turn this. I think I want to be able to define a, like a plane of motion as it vibrates. So like I like the idea of having a loop of paperclip that I can then like I can bend both pieces of that loop. So I think that's a positive. So it's possible maybe I make the vibration piece just totally separate and just like have one paperclip that goes in for the mount and one that goes in for the vibe motor. I've just made this a mess. Once it's at this point, it's usually alright to start kind of massaging it around to get the melted parts out of the way and reveal the colder parts. But I think I might have also heated it up so much that I'm a little afraid to touch it right now. So I'm going to heat it a bit more, just like this, with the heat gun, and then let it cool slightly, and then try to knead it a bit to get the heat a little bit more evened out in the center. This could also be probably solved more easily with a water bath, but I'm feeling like doing it this way right now. Hovis on YouTube chat suggests Googling Matthias Wandel plastic repair. Okay, plastic repair. I wonder if I did see that video. It's starting to sound more familiar now. Oh, and then Mike's radio repair says that I could probably put a $100 price tag on that and sell it to an orthodontist. Maybe the one from Little Shop of Horrors. That guy wasn't supposed to be an orthodontist, right? He was a dentist. I don't know. I mean, I don't think he was actually a dentist, but... I'm gonna give this a rest with the heat gun. Taffy. That'll be easier to get off once it cools. Yeah, Nick Poole says, judging by the song name, they're probably a dentist. Yeah. Yeah, so now I've got this. I probably should, like, so this stuff comes in pellets, but inevitably I reuse it a bunch and then end up remelting it, and end up just like with wads of it. But keeping it in like stretched out sheets is probably more convenient than wads of it, because then I can remelt it easily. Alternatively, if I had a plastic grinder. Yeah, Thomas has a good question actually. They say, so what's the point of this plastic? It looks like hot glue, but worse in every way. And yeah, I mean, it's better than hot glue in a couple ways. So with hot glue, if you touch it, it just instantly burns you and sticks to your finger and is no good. This stuff, if you're careful, you can actually mold it by hand. And it doesn't stick to your hands, so that's a big plus. It also, as a couple people have mentioned in chat, when it cools, it's like rock hard pretty much. It's more like nylon, whereas hot glue is usually kind of squishy. So that's why I'm using it here, because I want that rigidity, and I don't want to have to use epoxy. I want to see if I can get away with using this instead. And there are various ways of heating it up. You can use a water bath, which a lot of people use. You can literally just take like water from a tea kettle and pour it over a lump of this plastic in a mug, and then just come back and play with it, and that's pretty convenient. The one reason I don't like doing that is then it gets water pockets in your plastic if you're not super careful. So I tend to prefer the heat gun approach, but you know, there are a lot of different ways of doing it, and the water approach is probably fine for most purposes. I just get fussy about it. Andrew says that there are more rigid kinds of hot glue. Yeah, there are a lot of different formulations of hot glue. I don't tend to have a bunch of different hardnesses around. I think I just mostly bought a bunch of general purpose stuff, and then I have some black hot glue and some low temperature hot glue, but mostly it's general purpose. Cool Lantern says, looks like an oddly malleable ice cube. Yeah. Oh, and then James adds that you can hot wire cut polymorph. That's cool. I did not know that. I don't have like a purpose-built hot wire cutter around here, but I could probably fudge something together. Like, I've definitely got just like scrap nichrome wire hanging out. Hint says, so what you're saying is time to roll it into a hot glue stick. That doesn't work. And I tried to get that working. I sacrificed a very cheap hot glue gun to the effort, and I couldn't get it working. This is now cooled onto my cutter. Oh yeah, Schufel says building a plastic crusher and filament extruder is on my long-term goals because I want to be able to recycle 3D prints. Yeah, right. I'm gonna just toss this back in the pile. I keep looking into that. I feel like every couple of years I'm like, can I do this yet? But like, I think the place I keep getting stuck is on the, like the crusher is just like this big, awful machine that I haven't really wanted to have around because it's large physically and requires a lot of electricity and a lot of space, and so far has not seemed like something that would be worthwhile. But yeah, I mean, it seems like it's getting closer, and I don't know, maybe like just something that doesn't need so much energy, so maybe you crush the plastic slower, like grind it rather than just like have a wood chipper kind of thing. But yeah, the systems I've seen right now, they're still in the range where, like, to get started with all of it, it would probably be, like, on the very, very low end. Maybe a couple $100 for the extrusion setup, but more if you want consistent results. And then, like, grinding would be more like, you know, $1,000 to several grand, depending on the setup, and would require a lot of space and be very, very noisy and power intensive. And like the reason I bring up like the noise and power and all that is it's like, well, it just changes where you can do it. Like I don't think I could do it indoors here. I'd have to like go out in the parking lot or something, just because I don't think I can run like basically what amounts to a wood chipper in my unit here without it. I mean, I don't know. People do a bunch of disturbing stuff here. Like it's an industrial area. You can do a lot of stuff, so maybe that would be fine. But like, it's, I don't know. It's not great. Maybe they're less bad than I'm imagining, but I would probably at least need more electricity, like run another circuit to the breaker box. I think this is all melted. Anyway, I didn't necessarily need to heat up all of this. I guess I got a little carried away, but we can at least spread this so that it is a little easier to work with now. I'll cut off a little bit and break that into 2 pieces. I'm going to take one piece and just kind of casually mold it to the bottom of the toothbrush here. I'm going to take the next piece and put it up here, and I will hit that with the heat gun momentarily in a bit. And then I'm going to take another piece off of here and mold that around that, just kind of for fun. So my theory is that that will kind of sort of stick, but not especially well, that this will actually be really good, and that this will be good at protecting the wire, but probably not stick super well to the toothbrush unless I also hit it with the heat gun. That's my theory, but we'll see. I'm trying to heat it kind of near the interface because this stuff is really not very thermally conductive, but not just overheat the toothbrush itself that much. I also don't necessarily want to have to include a heat gun in the list of materials for this project. Ooh, I can actually see the 2 plastics wetting into each other a little bit. Just on that edge so far. Maybe they're just both getting shiny, actually. The angle of contact is changing a little bit, but not that much. Anyway, I'm gonna leave that alone. Jeez, let's not drop the heat gun. I'm gonna leave that alone for a bit. Alright, I'm gonna let that cool for a second. See if I missed anything important in chat. Eekpie says, headless toothbrush, can you SSH into it? Oh yeah, that's a good point too, that the Tinkering Corner brings up an issue with do-it-yourself recycling, especially that if you have contamination in your filament stream that you're producing, then that eventually gets in and clogs your hot end. I mean, yeah, that's true. I mean, I feel like you kind of have to clean your hot end a lot no matter what, but I can certainly see how it would decrease your print reliability. It's really tempting to hit the stuff with freeze spray, but you can start to see, if you look closely, where it cools, it starts to get opaque. So it's transparent when it's hot, and it's opaque when it's cool. It goes from this gooey, transparent state to this kind of hard, opaque, white nylon kind of state. Okay. Well, is there something else we can do while we're waiting for this to cool? Okay, so what's the plan so far? Let's just strategize a bit. I still need to test some specific toothbrushes. So like, for example, this one, I think this will probably work, but maybe after I pull out some of the bristles. It seems like attaching this to a central body made of paper clips is the right way to go, and to heat up the paper clip and just melt it in here and then adjust it by bending the paper clip. Oh my gosh, Ryan said some dude on Instructables uses a cross-cut paper shredder to grind plastic. Do you mean like plastic bags, though? I can see how that might work for like rafts, maybe, but like nothing thicker, right? Or is this some paper shredder that's different than what I've seen in person? How hot is this? It's still squishy. It's still squishy. I shouldn't touch that because it's squishy. This is starting to cool. It's got a nice waffle pattern up there. Alright, so I think the plan is to use paperclip ends here, and then have a pattern of paper clips twisted into a triangle in the middle. I still don't know exactly how that interfaces to either the magnet or the pen holder. Oh yeah, Eekpie is saying, are those tongue scraper nubs soft? I was picturing them on the last screen instead of the bristles. Yeah, I saw some toothbrushes that had those, but like not in a sufficient proportion for it to be like that great. I don't know. Or do you mean like, are there like separate things that are just those? Those are a lot like the little bristles that are on the little hexbug wiggly robot thing that my cat likes that we were showing earlier today. That seems kind of nice already. Like, that might not be perfect strength-wise, but it feels pretty good. That's pretty rigid all through that joint. Oh, I like that. So also look at this spring resilience. So this is the copper wire. If I'm trying to use this as a spring, this just bends really quickly. Whereas the paper clip, that has a pretty nice spring to it. Ha! Andrew says, could you just hack external control wires into some hex bugs? I could, but that would be not the most effective way of getting this done. They're kind of big and kind of expensive, and like a toothbrush head is cheaper and smaller and probably a little easier to hack than the hexbug thing, and a little bit more ubiquitous. Yeah, this toothbrush is getting kind of gnarly. Alright, so then this is still soft on here, the one that I hit with the heat gun most recently. This is hardened. Oh, and that comes off right away. So that itself does not work as an adherence method at all. It is tempting to hit that with freeze spray. I'll be right back. Tuco always eats the straws off of my air dusters. That is still kind of warm, actually, in the middle. But it seems like it's kind of bonded to the toothbrush. I'm going to hit it with more freeze spray. This is a very lazy sort of test. Man, what did I do to my finger to make it hurt all of a sudden? Ended DevPro's asking what this contraption is. I'm working on a new revision of this little vibrating robot that tries to draw pictures. And let me just grab some of the pictures it's drawn so far. It's been drawing stuff kind of like this, where it vibrates around randomly, but then there's some software telling it where to try to go. So this is not as good as I would like it to be working, but this is the best I've got so far, and I'm working on new variations in the design to try to make it better. Well, oh well. Yeah, so once that's cold, it just comes right off. I left a bit of a mark where I distorted the surface of the toothbrush with the heat, but it didn't actually bond that well. So, okay, well it looks like this is the way to go then. Let's just make sure that this doesn't crack off too as soon as I hit it with a bunch of freeze spray, in case that was the issue. Just watch, this one's going to be the YouTube thumbnail. Yeah, it has a little portfolio. Yeah, exactly. That is still pretty rigid. I think we're fine. So yeah, I think that's the way to do it. And then either incorporate the vibrating motor into the shape lock entirely, like from multiple sides, or solder it. James says I just put one of these on my fridge. If it's going on the fridge, it also needs a magnet. Oh, don't you do that stopping automatically stuff. Where does the magnet go? You just incorporate that into the shape lock, which would require me heating up the shape lock again and then pressing a magnet in. Let's do that later. I don't feel like fussing with that right now. I'm just going to put that aside. All right. So we've got the toothbrush head. So starting with a paper clip again. Well, let's use this one. I think I already gotten this one into the shape that I wanted to use for the test, and this is basically accurate. I want to squish this loop together more tightly, and then strip off the plastic. Thinking about where to attach the motor. It's like easiest if I can attach the motor like right here at the foot where I'm melting this whole thing into the toothbrush. But maybe, maybe I use this reversed like this. So maybe this is the tip of the foot. The motor goes kind of at the tip, like in this triangle, basically. Which means it's maybe like that and like that. And then this goes in like that, perhaps. Oh, you mean the drawings on the fridge. I get it, yeah. Yeah, that makes sense. Okay, I need to trim a little more of the insulation off because this is still going to embed unnecessarily. This stuff is annoying to trim. Did I mention that already? Definitely not using coated paper clips next time. This is just all I had handy. I might have trouble getting enough heat into the non-coated paper clips if they're not tinned and they're steel, because the soldering iron is not going to stick, really. But I should also probably just do this with my bad soldering iron tip that I use for plastic stuff, so that I can seal it off on top if I want, and so that I don't have to worry about touching the plastic with the tip. So I'm going to warm that up. It's not even plugged in. And to plug in the right soldering iron. Alright, that's warming up. So warm up the soldering iron with the sacrificial plastic welding tip. Whoa, the plastic on that was kind of fluorescent. It's a good question from NJDevPro, who asks how the motor, or how the motion is distributed to the different motors. Yeah, it's kind of in depth. Like the short answer is, as James said, each side of the robot has its own motor, but there's a lot more. There's a lot that goes into figuring out which motor to turn on when, and A lot of the last couple streams have been spent working on the software for that. And it basically does raycasting, where it looks at where it currently is according to the tablet, and then it has a kind of an ongoing estimate of where it would move if it turned on a particular motor, and then it casts rays out in those directions and just tries to pick the best direction. Solder does not stick to this tip at all. All right. Okay, so just thinking first about using maybe the outer ring of bristles. I think I want them pointing toward the middle of the robot, so I think I want the leg like on this side. That means I put the toothbrush. The handle was on this side toward the soldering iron. So I'm actually going to be digging into the head of the toothbrush with the paper clip then coming out kind of the opposite direction of the handle. That needs more sturdiness. Can I get both sides actually in the stick vise jaws? I think I need to use a different vise for this. When I'm saying raycasting, like, it's not that involved because it's just a 2D image, and it's not really making any attempt to provide like exactly numerically correct sampling. It's all very approximate. So what it really amounts to currently, like, I've even simplified it a bit since the last couple of revisions because I needed to make something that worked quickly enough that I could do with numeric Python. So the current raycasting involves taking the location that I know from the tablet and the candidate directions and normalizing them to a particular magnitude, and then just casting a series of points out in that direction and then sampling all those points from the image and then summing them together. That's pretty much all it is. I'm trying to keep that out of focus, clearly. Okay, trying to keep most of that flat against the surface of the toothbrush. I don't think I'm quite getting enough energy in there fast enough. It's close. Oh, maybe we're getting there. This is not so great. I probably would have been better off hitting this with a torch. is only making the slightest imprint on there. Torch. I think partly this is bad thermal transfer, partly this is just the wire being a lot bigger than before. Can I turn up the iron anymore? Iron's already kind of high up, I can turn it up higher. It's better at melting in like the area right under where the soldering iron is. It's better than nothing. I don't know how I'm going to get a strong joint just with that though. Unless I just have to push the wire down through the plastic with this tip, which is, I guess, maybe where I'm going with this. Yeah, I like that. Just sink it under. And the other side. Try to keep the whole thing down. Oh, this is gross. Sorry. I don't know if this is actually how we're gonna do this for realsies, but it's a good experiment. Letting it cool a bit before I let off pressure. I think it's mostly cool, but I'm going to start blowing on it gently just to help it finish. I'm seeing a bit of a phase change as a result of that, so I should be very gentle. Well, I think that worked. That was not quite as easy as I was expecting it to be, but I should let that cool a bit, but I think the next step is to shape lock on the vibe motor. So yeah, we've got paperclip, bristle, thingy, very bristly at the end. And then I want to just kind of play with this and see in what ways, if any, is it good at actually pulling, and how do we want to actually attach it to the next piece. Alright, so here's the vibe motor we've got pre-wired with our tiny wire. This is one of the Adafruit super little vibe motors. And then I've got a twisted pair of 32 gauge magnet wire powering it with a little bit of enamel coating the solder joints. And I've got some shape lock. I'm going to go ahead and start heating up some shape lock. And just remelt these pieces that I don't need anymore back into the pile, and then grab a piece from the other side probably. NJ Dev Pro says don't breathe the fumes. Yeah, I hope that's obvious, but yeah, for sure, don't breathe plastic fumes. The place I'm in right now is super, super drafty, so I don't need to worry about it unless I'm doing a lot more plastic cutting, but yeah. If you're doing it in like a regular room, then definitely be sure to have lots of ventilation, and if possible, do it outside. Ryan says, toothbrush smoke, don't breathe this. Yeah, exactly. Does anybody still watch the Blender channel? What is that even called anyway? They would just put terrible things in this blender, and they were like selling blenders, but it turned into this big old internet meme. I don't know why I'm explaining this, I'm sure everyone knows this already. I guess since I've already heated this side of it, I might as well just take a bit of it. Will it blend? Yes, that's what it's called. Sorry, the name was escaping me. Alright, I think that's enough heat. This does actually burn you if it sticks to your skin, but it's pretty easy to keep it from sticking if you keep it moving. Alright, so I'm going to try to do this without completely permanently sealing my motor in too badly, but it's going to be a little challenging to get out, I'm sure. So I've kind of encased this disc from most of the sides. I left a bit of an opening so that I can get it out a little easier later on this side. But I've mostly encased it, and I'm trying now as it cools to be careful to keep this pointed so that the toothbrush is kind of on axis with the rotation of the motor, because I think that's going to be important. Doesn't matter that much because we mostly just need to get the toothbrush moving, but it'll be more efficient the closer this is to on axis, so that'll be a thing to set now, and not really a thing that we need to worry about adjusting later, I hope. Alright, so I've got that kind of set the way I wanted. I could hit this with the heat gun again to seal the plastic a little bit more, but I think it's going to be fine, like based on the test that we just did on the other toothbrush handle. So I just want to make sure that cools with the motor in about the right place. It's going to adhere to the paper clip here, and then it's not going to make a good bond with the top of the toothbrush head, but it'll kind of sit on there as long as the paper clip is holding it. Should I hit it with the freeze spray? Oh, yeah. Oh, yeah, I guess they've been doing more Will It Blend. I haven't seen any of the recent stuff. It is like 9:30 here. I probably shouldn't stream all night, but I wanted to at least try these new brushes since I went brush shopping. So that's kind of cool. We got the motor. Clear out the fumes from this stuff. Speaking of ventilation. Alright, I think I'm done with the shape lock for a sec. I'm going to put this aside. And I think we've already established that this rubber soldering mat is a completely different surface than the paper we're actually going to be trying to draw on, so I'm going to get a little bit of paper. This leash is really going to need to be way longer in the actual thing. Ha 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 ha! Ed is wondering if Hydraulic Press has done a blend tech yet. Yeah, right? Gotta get all the channel crossover. Sorry, more light in the digital camera frame to make this actually look good. Okay, so this is connected to the power supply, which is just turned off right now. It's kind of free to move, but a little bit restricted, which is going to be kind of a problem. I'm going to try to just angle this down so that I can give it a bit of a training wheel. I might even just actually, just for the sake of simulating something else that's actually attached to this, I might just put another ball of shape block on the end of there. I think it's still warm enough I can grab a hunk of it. This will be a stand-in for the rest of the robot. That'll need to cool a bit before I can do much with it. Oh, of course there has been. Great. I'll have to watch that later. I should really let that cool before I do much with it. It's not solid yet. That is approaching solid. This is still quite squishy. Oh, it's getting there. It has a pretty quick transition between squishy and solid. Alright. Are we ready to turn this on? We're about to see if this actually does something. I'm going to start at 1.2 volts. Contact. Whoa. What is it doing? I like it. I don't think it's right, but it's cool. The brush is definitely staying off the page. This might be fun to look at in high speed. It might also be time to start pulling bristles off the brush. Because I think we are getting basically the same thrust from these forward and backward bristles right now. Yeah, that's pretty satisfying, even if it's wrong. I think maybe the next thing to do is just to pull some of the bristles off. I think on this one, I can do other experiments with other toothbrushes, because I got a few toothbrushes here. But I think I want to try removing that middle section of bristles. I think I can just pull them out with pliers. Let's see how far I get with that assumption. Ooh. Oh yeah. Bristly. It's like 3D printer trash. There are little brass ferrules in some of these, holding the bristles in. So I do actually have to apply significant torque to get that out. I think this is better than cutting the bristles off, but I'm not totally sure. Like, it's pretty clean and satisfying when I yank them out this way. Let me see if I can get some of this on the camera a little better. Oh yeah, Andrew's asking if I've seen the machine that puts them in. I've seen some of them, yeah, like on the good old factory YouTube shows. Yeah, I'm a fan of that stuff. I should get this wire out of the way somehow. A little bit of tape down here might actually help it out. That's a totally separate experiment, probably. I guess I wasn't expecting the ferrules. I thought they could just be heat pressed in, but they have little bits of metal in here. A couple more bundles. I'm just pulling out all the ones in the middle that are pointing in one direction, leaving only the ones pointing in the other direction. I just made a great mess. Okay, let me clean up this mess slightly, and then... That is pretty satisfying though, having like a hollow brush. It's pretty nice. I'm gonna leave the wire just kind of loose at first. And nice vectors on the page now. Yeah, I hope so, right? This looks like a good vector factory, right? This little modified thing. So what we've got so far, we've got a toothbrush that's been beheaded, and then we kind of plastic welded the end of a paper clip in it, and then used shape lock to rigidly attach the vibe motor to that whole thing. And I don't know where that's got us, but we're about to find out. So here goes nothing. Whoa! Oh, there it goes. That just wants to go. Look at that vector. Yeah! Oh man, I just want to build 2 more of these now. Andrew's asking if I could do this with a nose hair trimmer. I'm not quite picturing what you mean. I feel like if I let this run away uncontrolled, I'm going to put a lot of stress on the wires for the motor, but this is great. This is only 1.2 volts also. Can I go any slower? Here's a 1/2 volt. Oh, that's beautiful. That's a 1/2 volt, and it just scoots right along. Okay, so well, we haven't shown yet whether or not this can provide enough isolation to drive in multiple directions, but this is a pretty good little single direction bristlebot. Oh, to remove the middle bristles. Yeah, I think it might be easier just to use like side cutters like this to remove the bristles, I guess, but it was satisfying to pull them out. And that just leaves a bunch of holes, which was kind of fun. Man, it's really tempting to use that as a drilling template, right? To like imagine just drilling in there, extending those holes, looping a paper clip in and then back out. That seems like it'd be cool too. But the melting into the top thing seems to work fine, and that's pretty rigid. So in the center, I haven't totally decided what to do with the center. I'm imagining that the 3 bristlebots all just share kind of a common endoskeleton of twisted together paper clips. I'm a little worried that we might need more fluff, like more of a squishy center to keep the different vibrations isolated, but I don't know. I think so far I'm liking this, and I kind of want to move forward with this design, so I'm thinking that maybe I want to build just 2 more of this exact same thing, and then try different centers to see if they combine properly. I also kind of want to protect these wires more. Like I might just put a little bit of tape right there to keep that wire attached to the knee. Like I'm kind of imagining that's how it would work, with a bit of a wire spring to kind of distribute the vibration across that wire to avoid weak points. Ha ha ha! Eekpai says, I have a feeling the final result will be too perfect. Yeah, maybe. We can hope, right? Could you hide the vibe motor in that little hollow on the bottom, asks Andrew. That's an interesting suggestion. Do we have enough room? The vibe motors, I think, are supposed to be 10mm diameter. That seems about right. So what is the depth of the bristly thing here? That would be really close. I don't think we could safely get away with that. I think it would end up hitting the paper. But it would be close. Like, you might be able to get away with that if you were careful, or if you carved out a little bit more space. I can't believe this thing runs on 1/2 volt. This is 1/2 volt at 10 milliamps, according to my power supply. Yeah, I mean, I'm hoping this would be a great little, like, kind of educational project. Like, I'm hoping that the end result here is something that uses cheap materials, widely available tools, and then gives you this result, which is an inspirational illustration of kind of harnessing randomness by creating a closed-loop control system. Like, ultimately, I want this to be a project that's about closed-loop control, but it could also be about a bunch of other related stuff. Oh, you're asking how low it can go. That's a good question. I think it cuts off between 0.4 and 0.5. It's hard to tell. There's a little bit of current draw at 0.4, but I can't feel the vibration anymore. Oh, it is vibrating. I can see the wire moving. Okay, it is vibrating at 0.4. And it might have stopped at 0.3. And it doesn't start reliably again at 0.4. Definitely starts at 0.5. And then stays running when I bump it down to 0.4. Now it's at 0.5 and isn't started. I had to go up a little higher for it to start that time. I had to go up to like 0.7 to get it to start that last time. Okay, it's pretty good though. Oh, nice. Eekpai says, I remember my cousin a decade ago programming a brush bot in BASIC. It only went left or right. This could be fantastic progress. Yeah, I mean, it doesn't seem like you need that much more than just like left or right for it to draw full images, right? That's kind of what I'm trying to explore. All right, how do I want to protect that wire? A little bit of tape would be the most straightforward thing, but I could use heat shrink if I want to get fancy. Let's think about that while I just build a couple more of these. You know, I kind of like this wiring strategy. I wasn't quite sure how I was going to do the wiring because I hadn't really decided where I was going to do my common point, how the individual motors were going to connect back to the robot. But I think having a little twisted pair going to each motor is probably going to at least mechanically help out in what we're doing. I think I actually want that Oh, see, here we're having that issue where this actually stuck to the coating pretty well. Oh, nope. Not quite well enough for it to take the coating with it, but there we go. Let's try using heat shrink. Oh, I think I might have some that's just a little bit wider than the legs here. Yeah, I feel the same way. NJDevPro says the motion looks surprisingly consistent, which is good. Yeah, exactly. I was thinking about how to mount it, like all while I was shopping and walking back from the store, and I think this thing where I have the motion at the end of the leg and then have this adjustable arm, I think that's going to prove to be really useful. So let's try putting a little bit of heat shrink over this. A little bit annoying because I've got this little blue flag on here. I'm going to try to trim the flag. The blue thing is supposed to be indicating which wire is negative. I don't know how much it matters, but the motor had a polarity marked on it. So that's going over the tiny wire. It's going down the curly part. And then I don't need this wire to be that long ultimately because I think, well, you know, I think in the final version of this I'm probably going to find a way to just do this with more continuous wires and no joins. I think right now I'm just going to assume I probably have some joins on the center part, like between these motors and the leash part. Just because I think I want to twist and build the leash part separately from the motor parts, just for mechanical reasons. So that said, I think I have, like, I can use as much of this as I want for strain relief. So maybe at least that much for strain relief. Now I just want to aim these so that they're not overlapping, they're just kind of spaced out so that I can keep the wire from being too stressed at any one point, like kind of like that maybe. That might be too long. Pulled a little bit of the wire through and now I'm just evening it out. I think that's closer to what I wanted. That enamel joint was going to be temporary, but I think that might not be temporary anymore. Okay, so that's my current thing. This moves, there's some strain relief with the wire, a little mechanical decoupling, not too much. Okay, so this will be our reference. Let's try to make a couple more like this. I guess that means we need to test out new toothbrush beheading methods. So these are the brushes we're using. These are the Target store brand Deep Clean, Zigzag, Value Pack, Soft, etc. And I already had one on the desk here, this yellow one. Let's also use this other yellow one, why not? I guess they're different shades. There's like lime and yellow. Guillotine. Wouldn't the rotational energy push it left or right along the axis of rotation? It'll torque it, but I don't know if that'll have overall very much effect. I don't have a laser cutter, sorry. There is a laser cutter in the building, but I'm shy. This is what I was talking about using, maybe. Just get it started with this and then trim them with the side cutters. Because I don't need to keep any of the neck, really. Yeah, right. I'm glad I'm not the only hopelessly socially awkward person here. Kate says that it's worth the $1,000 not to have to talk to someone to laser cut. Yeah, right. Although I should talk to more people to laser cut. It's hard to do. And it's like I offer my tools to people too, but I mean I know that they probably have the same problem a lot of the time. So I'm just kind of doing this to taste, basically just cutting off everything I can, which rounds it off based on the shape of this tool I'm using. Could I have just done this entirely with this cutter? Yes, okay. The other cutter was completely overkill, at least for this toothbrush. This one had a pretty thin neck, though. Not all of them do. I should maybe just try beheading a few different brands of toothbrush and compare them. I do need to make sure this works with multiple types of toothbrushes, that I didn't just like get lucky and find the one kind of toothbrush that this works super well with. Alright, so that's kind of up. I think let's pull out the bristles next step. So I'm gonna save these handles with the other one for now. Might throw them away later. Pruning shears. Can't really trust the autofocus with this, can we? How hard is that to grab? I feel like I keep needing to rotate against the rest of it to get leverage. And you have to be a little careful doing that not to mess up the bristles you're actually keeping. These pliers are not the best tool to use for this job, I think. Okay, how bad is it just cutting them? Got a bit of brass in the way too. Getting the whole ferrule out is really satisfying. Actually, pulling them with the cutters is not terrible, since you can get really in between them. Some of these I managed to pull the strands out around the ferrules, leaving the ferrules entirely in place. What is it like if I just cut? It's actually kind of hard to cut. we go, I left a good wad of bristles in there. It's much more satisfying to pull out the entire bundle than it is to cut them off. Even if it would probably be sufficient. A lot of laggy little ferrules in there. I have to pull out now with tweezers, I guess. Because they're just going to fall out later and become sharp debris. I told you we'd be doing toothbrush surgery, right? Oh yeah, that's a good point. Frumprino says to make the project bill of materials similar, can you use vibro-motors from cheap toothbrushes? Yeah, maybe. I've certainly seen people do that, where they use the motor and the toothbrush from the same place. I think with that, it's just, it means that like you have fewer things on the bill of materials, but those things are a little more specialized, and I don't know if that's a great trade-off. But it really depends on exactly what the sourcing is like. Like if they're easy to find, then that could be a good option. I think that last one is pretty deep in there, so I'm just going to leave it. I was just taking off the ones that seemed like they were going to come out on their own. Alright, so we've got that one prepared. Neck cut off, middle bristles removed. One more for the middle bristles. Can we try a different technique for this one? I feel like the thing I just did was really bad, and I'd like a better way of doing it. I mean, pulling them out seemed alright. Maybe I'm just using the wrong tool. I don't know, the pliers. Cody's asking if we're talking about something other than motors? I don't think so. I mean, there was like a brief conversation earlier about using solenoids, but I don't think we've had any serious prototyping thoughts for non-motor based versions of this. A little bit of damage to some of the other bristles occasionally, but I'm mostly being nice to them. This is annoying though. It would be worth it to try to find better brushes, but so many of the brushes did not have favorable orientations. Some folks, I think later on, oh, where was this? Was this on Twitter? They were suggesting like dollar store brushes, or maybe this was in the chat. Because yeah, I was going to Target, but yeah, maybe a dollar store would have had a better selection. It'd be nice if they made a clear color difference between the ones I was supposed to be removing and the one I'm not, but there's some overlap in the colors they used for each. I do have 4 of this kind of toothbrush. There's 1 more than I need for a single robot at least. I could try the other kinds if I need to. Talking about having a quadcopter swoop down like an eagle, and now I've got fly like an eagle stuck in my head. Thanks. All right, that one is cleaned for the most part. There's a couple of ferrules that are nicely stuck in there, but nothing I'm gonna worry about. Let's take care of some of this bristle mess. So there's our good one so far. These 2. I'm gonna do the thing where they're all different colors, maybe. So I think this was kind of haphazardly bent into a foot. Try to keep this consistent, doing all the steps on all the robots. This one even stands up on its own, this little leg. That's cool. I think this whole thing will need to be less long, because I don't want the footprint to be that wide, definitely. But we can easily bend them later. I just want them all to be about the same right now. Be a little easier to test them probably if they're more wide and I don't have to keep worrying about them falling over. Yeah, I think I did that. I unfolded that last bend and kind of moved it slightly down. That's why it's a little bit kinked like that. Oh, and I probably should have cut the... I don't know if it's easier to cut the insulation off before or after. Probably before, but it's not what I did. Mike's Radio Repair says, hey, you just invented the motorized scrub brush. I definitely did not invent this. I mean, the earliest reference I could find to this particular kind of vibrating robot was actually maker Wendell Oskey of Evil Mad Science documented this kind of bristle bot. And I think he was saying on that blog that that was the first time he saw, like he hadn't seen like a toothbrush being used specifically, and then the toothbrush idea got really popular. Because it is a good form factor. It's not perfect, but it's pretty good and it's widely available. Cool. Yeah, I feel the same way actually. Eat Pie says I'm oddly excited and invested about this project. Right? I don't know why it's so interesting, but it is. I don't want to stop streaming, but I'm also realizing that I should eat at some point. I probably should have eaten something before starting this, but I was just so excited. Like, I bought a bunch of food at the store while I was also buying these paper clips. Or not the paper clips. I should have bought more paper clips, but these are the paper clips I had, which are clearly not optimal. But now I was buying the toothbrushes and food, and then I just didn't eat any of the food. I have beer, but beer is not food, as much as it tries to be sometimes. I need a pizza button or a sandwich button. Yeah, either of those would be great, actually. Now, I've actually got some food. I just need to throw it in the microwave and eat it. This is awkward to trim off. Is it better with a knife? I don't really care about what tools I use to get this off, because this is certainly not part of the final build. I'm just, oh, a knife helps a lot, actually. Cool. Okay, I think that's enough of that. Is this stuff coated differently? I think it's just acting weird. I think it's still basically the same plastic coating. It's just hard to get started cutting into it. Booze ain't food. Yeah, maybe I just need to change how I think about that. Guys, I'm trying not to become an alcoholic. Oh man, yeah, it finally broke through the... It felt like I wasn't even sure when I was fully through it, because the plastic just... It's so weird. It's not like regular wire insulation where it just comes off easily. It's like really molded onto the wire. Well, not like regular insulation isn't, but I feel like regular insulation is at least designed with wire stripping being an important property, and that's not really a concern for the paperclip folks here. Ooh, single-use disposable phone chargers? That sounds terrible. I've seen those, but I don't know why you'd want them, because they just seem bad in every way. Like, bad for the environment, just like a bad way to charge your phone. Like, maybe if you're desperate, but... Like, I could only see that being applicable if you're in a spot where that's like the only thing you can buy, and you couldn't just buy like a plug-in charger instead, or like if they're selling it for a little bit less than the plug-in chargers or something. I had it pretty well started on half of this, but I couldn't get it to round this corner. Eekpai says, I bought one, took it home, and used the battery in a project. That's nice. That seems like a good use for it. Oh, is it coming off finally? Whew. That was annoying. Okay, no more of that. Gotta really get some uncoated paper clips here. Okay, I think these are roughly good. I need to make some more of this twisted wire, but maybe we can do that while the plastic is cooling. Alright. I also am probably not going to get to the point where I'm finishing this tonight, because it's pretty late, but maybe I can at least get this particular prototype working. The one where I just have like an immobile blob in the center, and then three of these legs. Okay, my soldering iron with the sacrificial tip is still hot. So same idea here, that pushes... Oh, I need to reverse my foot here. Okay, like that. Ideally, I would not be putting these paper clips through so much metal fatigue. Oh yeah, I think I might have seen that video. Okay, I think that goes through. I need to reverse my foot here, yeah. Alright, let's try that. This shouldn't need to be that accurate. I just have to get it set somewhere that's roughly right, and then I can fine tune it by bending the paper clip. Does take some preheating. Maybe I need a sacrificial chisel tip. I wonder if I've got any old chisel tips. This is doing the job, it's just slow. You do kind of have to keep some pressure on it, otherwise it just wants to slide out. Might have to turn on the ventilation in a sec. Come on, a little further in, and then we can be done with this. Okay, I think it's further in enough. It's not very far in on this side, but I'm kind of losing my grip with the vise. think I really need to move the camera slightly further away for this. Yeah, AA batteries are pretty surprisingly packed full of power. Muli is saying hi from France, where it's 7 a.m., and saying that since this robot has 3 toothbrushes, the dentist will no longer have any customers. I don't know, did you see this other part we had? I think this increases the number of customers the dentist has. Let's get the fume sucker over here. Okay, this is not perfect, but I think it's maybe good enough. I think that'll do. We've covered at least like the top of that wire on most of its body, and once we have the additional plastic on top of that, that'll help reinforce it a bit. So let's press on. I think that's good enough. Let's do another one just like it. Maybe better. Gotta keep making sure I solder these the right way around. So both of these are right. The foot is soldered to where the neck was on the toothbrush, which is pointing away from the center of the robot. So if the handle was still attached, it would be way out here, pointing inward. These things are really springy. I keep like bouncing them around in my hand accidentally. It is getting late. I'm not going to have that much more time to do this, but I'm trying to at least get to a good stopping point. Turn this enough that I get enough grip, but not so much that it just pops out. Okay. Something like that. It's also still possible that the middle of the robot could be 3D printed. Like, even if the center of the robot is 3D printed, all of this stuff that we've been doing kind of makes sense. It just means that there's a bit of an eclectic parts list when it's all said and done, requiring 3D printed parts, and modified toothbrushes and shape lock plastic. But maybe that's what it ends up. I don't know. There's also plenty of substitutions, like if you don't want to do this, use some epoxy, or actually I can't think of any other options beside epoxy. There's, I mean, gluing it, or maybe some kind of 3D printed clamp, or maybe binder clips, maybe? This is so tenuous, like the vise is not actually holding this super well, so I can't really apply as much pressure as I'd like to. It keeps slipping a little bit. Here we go. Yeah, this step needs work. I don't want to have to explain how to do this to people, because this is terrible. Yeah, we'll have to find a different way to do this. I'm also melting the plastic on my vise now, because it keeps slipping down. I had it really close, and then I let it cool off a bunch, and now I've got to let it get hot enough that I can get it the last bit of the way there. I might give up in a sec. This is ridiculous. So I'm going to get that plastic off the iron before it decomposes while it's still actually structural. Okay, I'm about to leave this alone and see how strong it is when it cools. Trying to hold roughly constant tension as it cools. This whole part of the process is terrible. Okay, I can see it starting to phase change. So I'm gonna go of it for a sec. Ugh, that was terrible. Oh yeah, good call. Andrew says doing this before you cut the handle off might be easier. That's a good point. I should definitely do it that way next time if I do it this way at all. Oh yeah, Ian suggests a small bolt. That's also a great idea. Yeah, especially if it's like this where, because I didn't realize we'd have the center kind of empty like this, but yeah, a little bolt might be great. Or again, like drilling holes through and then looping the wire around. Because if we did just drill 2 holes, then I could just loop it in, then back out, then twist it, and that might be enough too, especially if there's shape lock on there also. So, a few options that are probably better than what I just did. Alright, and let that cool also. And heat up some shape lock. Oh, I guess I need to prepare 2 more vibe motors first, which means I need more of this twisted wire stuff. Yeah, M2 would be about the right size. That might be, can you get that on Adafruit? You can't, I don't think you can get M2 like at your any corner hardware store around here. But you could probably get something close. Let's see. pull out kind of a long length of this, like about arm to arms, maybe like 1.5 meters or so. And I'm gonna cut it, fold it in half, twist it. Or just a big box of them from McMaster. So remember, the end goal here is not just like me wanting to build one thing for myself, but me wanting to make a guide for how this is easy to put together for anyone. So that's why I'm not as concerned about just like, can I do this thing once, and more about like, can I describe this to people so that it's easy to do. Okay, like if Home Depot has M2, then maybe that's fine. I wasn't sure how easy it was to find, because like my kit of M2 stuff didn't come from Home Depot. Alright, I'm going to fold it in half, take the crease here, stick it in my drill, and do the thing again where the wire is thin enough that I can just stick it between my magnetic chuck and the tool. Oh, did I actually just cut it by doing that? I haven't done that before, but I think I just did that. Where did the other piece go? Yes. Okay, well, let me try that again. Not cut the wire. I've had better, more reliable luck doing this with an alligator clip in the drill chuck. I just figured I could get away with this. Alright, so alright, that's about the amount of twist I wanted. Yes, card. I think it would work to, like, if we're okay with drilling stuff through the toothbrush head, which I think is not too bad, like especially if you're going in from the bristle end and going in through one of these holes. Like even if we're not debristling large parts of it, like I think just taking a couple of bristles out to put the drill in would be a reasonable modification. And then, so all you need is a hand drill and a relatively small bit, and then you could just loop the wire in and then back out and then twist it. I think that would be good. That's probably the next thing I'm going to try as a substitute for the melting it in method. Because this is kind of annoying. Okay, I'm going to cut off the ends. And this is now just some twisted wire, which I can use for a bunch of stuff, because it's a little long for even both of this. Oh, I need to give it its second twist, though. So I was wrapping it around one of these mechanical pencils. Oh, Ace Hardware, yeah, they're good too. We have those around here. Yeah, we have, around here we have Home Depot and Osh and Ace, I think. Or is it True Value? Osh and Home Depot are the closest ones, but I think in SF there's a variety of hardware stores. Double helix, yeah, kind of. Alright, that's pretty well coiled up. And how much of this do I need? Oh, let's just clip about that much for each leg. I ended up with a little bit left over. That's fine. So I'll take each of those and try to actually label it this time. Make the attachment between that and these two vibration motors. It is actually kind of late here. Maybe I would be better served by restarting this tomorrow morning. You know, yeah, maybe let's do something slightly different. I feel like I don't want the stream to drag on too super much longer, but I do want to run that one test I had in mind where we do the vibration on one motor and see how much of an effect it has on the other legs. And I can actually do that without finishing all this wiring. So let's save the wiring for later. And I'm going to reattach these three brushes to the same little shape lock lump in the middle, and then just apply power to one of the motors and see what that looks like, and then call it a night. So for that, let's just heat this up with the heat gun again. Turn off that soldering iron and turn off the plastic fume extractor. And turn off this soldering iron. Turn on the heat gun. I don't know why my finger's hurting all of a sudden. I wonder if I got something stuck in it. Possible that was where I burned myself earlier. I don't know. You never know with these things. Speaking of burning myself, let's just do that again repeatedly. The bottom of that was not even remotely melted, and the top of it was really hot. It is actually kind of tempting to make the kind of coil bobbin part and the sleeve that holds the pen out of shape lock too. I think that would work alright. So I think the way that that's going to work is that I take the same 3 paper clips that go to the brush heads, I interlock them into a triangle, but then I mold shape lock around that whole contraption and then form potentially additional shape lock, or maybe just the stuff that I've already gone there. I form that into the actual bobbin kind of thing that holds the coil and the tube that holds the pen, so I'll get additional use out of that. I think that'll work out. Huh. CYC in the YouTube chat is asking, what is this sorcery? You mean the robots or the plastic? If you're asking about this stuff, it goes by a bunch of names, but polymorph, instamorph, polycaprolactone. It's a plastic that you can just hit with a heat gun, and then it melts at a low enough temperature that you can mold it by hand. If you're asking about the robots in general, I'm trying to make a drawing robot that works with vibrating brushes. You've probably seen these before that just like draw kind of abstract patterns. I'm trying to specifically make one that is programmable to draw whatever you like. This is just a prototyping stage. The actual robot is going to be smaller than this, but I'm just using this to try to see if I can get away with this particular brush arrangement. I should be more concerned with having these stick in there strongly than at a particular angle, because I can always bend them. First, now it's going to take a while for this to dry. Cool, I mean. Okay, this needs a lot of all sorts of stuff, but I'm going to just try attaching some power and see if we can get some at least preliminary results for that one experiment I wanted to run tonight. To see if I can move this, have it drag that, and have it not affect the other two especially much. I know this is not optimal, but this is what I have energy for right now, this late. And I'll do more tests once we have more of this put together. Okay, this is still set really low. It's at 0.5 volt. Wow, that's encouraging. Okay, so that's at 0.7 volts, and it still wants to go in that direction. These, I can feel the vibration, but it's not intense enough to really move them, whereas over here, that feels significantly stronger. Yeah. Oh, interesting. Yeah, that's a good question. I'm a little bit familiar with like piezoelectric motors, and I've seen some of the stuff that they do. Rubber Cats is saying, I wonder if it'd be possible to build a macro scale version of a linear piezoelectric motor vibrating different bristles out of phase with each other. Yeah, right? So far, it's been really unclear how we would get control over the specific vibration modes of the structure here, but like it'd be really cool to go that deep in here, and it feels like maybe with piezo actuators you could get there. So also, once I get to the end of this part of the leash, you can see it's like really easily restrained by that. Whereas, so I think one of the things that'll be really interesting to see is once I actually get the long wire that attaches this back to the Raspberry Pi, and I can see how it behaves on such a long wire, I hope. I hope that'll be nice. These little bits of wire, I think, are just going to be for connecting the individual brushes back to some central thing that then goes off to a strain relief. So yeah. Alright, I think that's basically the wrap-up point for this particular stream. We'll be back to this soon. Just for some reference on where we've been, the last two versions of this was the previous version with just like little wire peg leg things. And the main problems with this were the central part of the robot was too light and the legs didn't work too well. But this had the central insight of having the pen float relative to the bot, which was pretty cool. This was a more monolithic design that does not have a floating pen. The pen sits snugly into here. But this one was the first one and the one that I've had the most success with so far. So we're trying to beat this design. And yeah, I have high hopes for this one. I like the paper clips because they're adjustable, and I like the brushes because they're reliable at locomotion compared to the kind of single paper clip points. So highly engineered spring force restraint power umbilical, right? I like that. All right, and I think that's about it. Thanks so much for dropping by, and special thanks to everyone who puts up with me. No, I mean, it's really nice hanging out, and I appreciate it when folks share ideas and work on stuff together and send in hardware. And a lot of you also pitch in a few bucks a month on Patreon to help me pay the shop rent and keep this going pretty close to full time, and that's been pretty amazing. So thanks to everyone who makes that possible. And I'll try to keep it up. I'll see you all next time. Yeah, I agree. Frumperino says, exciting, hope to see these in a classroom soon, right? Like, if I can make this easy to build, it'd be great to see more people doing this and just have it be just a good experiment that touches on a lot of different aspects of control systems and building stuff and art. So, yeah, that's the dream. I'll see you folks next time. Happy hacking.